This is an example of a chi-square test of independence. A vaccine is available to prevent human papillomavirus, or HPV. A study looked at vaccination rates among Asian Pacific Islander students, AAPI, and white college students. The data is shown in the table. Test the claim that the vaccination rates and race are associated. So we have two categorical variables, the vaccination rates, so whether they completed the virus vaccination, and the race of the students. In this case, we're looking at AAPI students and white students. And we want to know if those two categorical variables are associated. So that calls for a chi-square test. So the first thing we need to do is we need to put our data into a table. And I wanted to show you how to do that in StatCrunch. So you really just recreate that table in StatCrunch, but you need to make sure that you put the headings of the table in the very top row by renaming your variable. So I'm going to put completed here, and here I'm going to put the AAPI group, and here I'm going to put the white group. Now the first row we have was how many did complete it. So for the AAPI group it was 136, and for the white group it was 1,170. And in the no category, for the AAPI group, we had 216, and in the white group, we had 759. So that's all you have to do, is just enter your data into the table. And so I'll write this pathway down on the notes that we're going to provide, but basically to get to the chi-square test, this is a little tricky. You come here to stat, and you have to know that your data now lies in a table. So we're working with a table. And the type of table this is called a contingency table. And we have a summary. So the data has been summarized into a table. Our columns are the AAPI group and the white group. And our rows are whether or not they completed the vaccination. Okay? And so we'd like to do a chi-square test for independence. We'll compute. We're going to come up with a test statistic, a chi-square statistic of 58.9, or that could actually round off to 59.0, but a p-value of very, very small, less than 0.0001. So we'll be rejecting our null hypothesis. So let's go ahead and write that down in the notes. So our null hypothesis is that these two variables are not associated. In other words, they're independent. So vaccination rates and race are independent. Or another way of saying that, you could also write, instead of independent, you could write not associated. Either of those makes sense, and you don't have to write both, just pick one. And the alternative would be that these two variables, categorical variables, vaccination rates and race, are dependent. Or another way of saying that would be that they are associated. Now in step number 2, the criteria for running a chi-square test is that all expected counts must be greater than or equal to 5. And I'll show you how to see the expected counts using StatCrunch. It will calculate them for you. But if all of the expected counts are greater than 5, you can do the test. Our test statistic, our chi-square statistic, turned out to be 58.96. And our p-value was very, very small, less than 0.001. So with a p-value that small, that says that this sample would be highly unusual. If your null hypothesis is true, you don't believe the null hypothesis, and you believe that the alternative is true. And so vaccination rates and race are dependent, or in other words, there is an association between vaccination rates. We'll write it that way. There is an association between vaccination rates and race for these two groups. For the white and AAPI groups. So let me go back and show you how to see the expected counts in StatCrunch. So here we have our setup again, and so there's a way to say what we would like it to display. So when it says display, just say please display the expected count. And then when you compute, the numbers in parentheses are the expected counts, and you can just verify that all of the numbers in the parentheses are greater than 5.